Welcome to the Deep Dive. This is your essential shortcut to mastering the knowledge that matters, and it's custom built for you, the professional learner. Today, we are taking a monumental plunge straight into the technical core of the ACCA Performance Management syllabus.
Yeah, it really is. PM is arguably one of the most demanding papers in the whole ACCA qualification. I mean, the syllabus is just immense. It goes from the really fine detail of costing methods right up to complex variance analysis and, crucially, those strategic decision-making frameworks that businesses actually use day to day to control performance.
And we know you're likely studying against the clock. So our mission today is really laser focused. We've pulled together a whole stack of expert study notes, formulas, calculation examples, basically everything we could find to distill this massive blueprint. We're going straight for the core, those high value technical concepts and the decision structures you absolutely need, not just to pass the PM exam, but, to really tackle those challenging Section C questions with confidence and speed.
Exactly. Think of this as the ultimate knowledge triage. Performance management, fundamentally, it shifts the focus of accounting, doesn't it? It forces us away from just sort of historical record keeping.
Right.
Instead, you have to leverage both financial and non-financial data strategically. The goal is always the same: optimize decisions, control operational efficiency, and really drive performance across the organization. Often in environments where different goals are pulling in opposite directions.
Okay, let's unpack this then. Let's jump right into part one. We really need to start where management has to start getting a clear picture of product profitability. And that means moving past some pretty archaic costing methods.
Right. So we had to begin with the foundational failure of traditional absorption costing. Typically, this system lumps all your overheads, the cost of running the factory, everything that isn't direct materials or labor, into one big pot.
Just one big cost pool.
Exactly. And then it spreads that cost across all the products using a single, often quite crude basis, usually something volumetric, like direct labor hours or machine hours.
And I guess the problem there is if you've got a company with a really diverse product range, maybe some high volume simple stuff and some low volume complex products, that single overhead rate becomes, pretty useless for strategic decisions, right?
Totally useless. It systematically overcosts the simple, high-volume products, and critically, it ends up subsidizing the complex, low-volume ones, the ones that actually chew up disproportionately more resources, like setup time, quality control, special handling.
So those complex products look cheaper than they really are.
Precisely. Which leads to terrible pricing and product mix decisions. Activity-based costing, or ABC, is the necessary answer to that kind of distortion. It tries to get a far more accurate allocation by recognizing a simple truth. Activities consume resources, and products consume activities.
Okay, walk us through the process then. For someone facing an ABC calculation in the exam, what are the key technical steps they need to nail down?
Okay, step one. You identify the major activities that consume overheads. These become your cost pools. Things like material handling, machine setups, receiving goods, dispatching orders.
So discrete activities.
Discrete activities. Step two. For each of those pools, you figure out the cost driver. That's the factor that actually causes the cost of that activity to increase or decrease. So if your activity pool is machine setups, the driver isn't labor hours. It's probably the number of setups.
Right, that makes sense. The number of setups drives the setup costs.
Exactly. Then, step three, you calculate the total cost for each activity pool, divide that by the total volume of its specific driver, and that gives you an absorption rate per driver. So dollars per setup, dollars per delivery, dollars per inspection, whatever it is.
Okay, got it. So multiple overhead rates, basically.
Multiple rates, each tied to a specific activity. And finally, step four, you allocate those overhead costs to products based on each product's actual usage of those specific drivers. How many setups did product X need? How many deliveries did product Y require?
Okay, let's make this concrete. The Una products example you mentioned from the source material, it really shows the impact, doesn't it?
It's a classic illustration. Uda products had three products, A, B, and C. Initially, they used a traditional labor hour rate, 2.836 cents per hour, I think it was, to absorb about $190,000 of overheads.
Yeah, under that old system.
Under that traditional view, product A looked like a small loss maker, about 78 cents loss per unit. Products B and C, though, they lived nicely profitable, around $2.16 profit each. So that's what management believed was happening.
But that wasn't the real story.
Not at all. Turns out, product C was actually a low-volume, highly complex product. It needed frequent machine setups, specialized receiving procedures. It was a real resource hog, but the traditional system hid that.
So what happened when they applied ABC?
When Una Products reallocated those same overheads using drivers like the number of setups, number of deliveries, dispatch orders, the true picture just jumped out.
A complete reversal.
A complete reversal for some products. Product A, the one they thought was losing money, actually turned out to be profitable, about $1.10 profit per unit. Product B stayed profitable, maybe slightly less so. But product C, the one management thought was earning $2.63 in profit.
Yeah.
It suddenly showed a dramatic loss of $3.63 per unit.
Wow, that's a huge swing.
It's massive, and that distortion is the key strategic takeaway. ABC forces management to confront those high-maintenance products that were previously hiding their true cost, subsidized by the simpler ones. The big advantage is you get superior, much more granular information for critical decisions about pricing, product mix, process improvement.
Okay, the information is clearly better, but implementing ABC, it sounds like a potential nightmare for the accounting department. Is that complexity the main drawback?
Absolutely.
Yeah.
That's the major disadvantage you have to acknowledge. ABC is complex, it can be costly to set up, and it demands really meticulous ongoing data collection on all those different cost drivers. You need systems to track setups, deliveries, inspection time.
And if the data feeding into it is garbage?
Then the allocation will still be garbage, even with the superior methodology. Data quality is paramount. So there's a trade-off between accuracy and implementation cost complexity.
Okay, so let's say we've used ABC. We now know the true cost of our products. The next step is setting a price. The traditional trap, as you said, is cost plus pricing. Calculate your cost, slap on a desired profit percentage, and boom, that's your price. But what if the market just won't pay that?
Exactly. That's where target costing comes in. It completely flips the logic. It's a purely market-driven approach. It starts with the customer and works backward, and it embeds cost control as an absolute necessity right from the start, not just an afterthought.
So it starts with the market price, not the factory cost. Walk us through the steps.
Right. Step 1. Determine a target selling price. This isn't based on your costs. It's based on thorough market research. What price point do you need to hit to achieve your desired market share? What are competitors charging? What will customers realistically pay?
Okay, market dictates the price. Step 2.
Step 2. Define the required profit. This could be a simple target, like Packard Plale, in one example, just wanted a 40% gross profit margin. Or, often it's more strategic, tied perhaps to shareholder expectations or investment hurdles.
Like the Hewlett example.
Exactly. Hewlett Plale needed a 30% pre-tax return on investment, ROI, on a $5 million project investment. That mandated a total required profit of $1.5 million, which then sets the required profit per unit you need to achieve.
Okay, so you have the market price, you subtract your required profit per unit.
And that gives you step 3. Calculate the target cost. Target selling price minus required profit equals target cost. This is the absolute maximum cost the product must be manufactured for if you want to hit your profit goals at the market price.
And then comes the moment of truth. Compare the estimated actual cost to make the product with this target cost.
Precisely. If your estimated actual cost is higher than the target cost, the difference is the target cost gap.
And that gap is critical.
It's everything. Because if that gap exists, the product essentially cannot launch until the gap is closed. This forces engineers, designers, procurement teams into value engineering, aggressively finding ways to take cost out. Can we use cheaper components? Simplify the design. Streamline manufacturing. Negotiate harder with suppliers. This often happens before the first unit is even made.
And if you just can't close that gap,
Then the strategic decision is usually pretty clear. You abandon the product concept. It's just not viable at the price the market will bear.
that proactive cost management, forcing cost reduction up front, seems really powerful. But I can immediately see why applying this in, say, service industries will be incredibly difficult.
Oh, absolutely. Target costing is notoriously hard to apply effectively in services. And it comes down to those classic 5 characteristics that differentiate services from physical products.
Right, the IIP criteria, sometimes called.
Yeah, or slight variations. You've got intangibility, you can't touch or store legal advice or a haircut. Inseparability or simultaneity, the service is often produced and consumed at the exact same time, like a lecture or a taxi ride.
Then there's variability or heterogeneity.
Right. The quality of a service can vary hugely depending on who provides it, when, and to whom. My experience at a restaurant might be totally different from yours.
Perishability, you can't store unsold hotel rooms or airline seats for later sale. Once the moment passes, the revenue opportunity is gone forever.
And finally, no transfer of ownership. You don't own the surgeon's skills after the operation. Because of these characteristics, defining a standard unit of service and calculating a consistent cost per unit to compare against a target cost is just extraordinarily challenging. How do you cost one unit of consultancy advice? It's very difficult. Hashtag 1.3 time horizons and lifecycle costing.
Okay, so we've talked about accurate costing with ABC and market-driven costing with target costing. Another potential trap is focusing only on short-term profitability. That seems particularly dangerous for products with really long development times or significant end-of-life costs, right?
Absolutely.
Yeah.
Relying only on, say, the first year's profit and loss account can lead to disastrously bad decisions, especially for things like new pharmaceuticals, major software platforms, or infrastructure projects. That's where lifecycle costing, LCC, comes in.
So LCC takes a much longer view.
Much longer. It mandates accumulating all costs associated with a product over its entire lifespan. That includes everything from the initial research and development, R&D, design, prototyping, through manufacturing, marketing, distribution, and crucially, all the way to the end-of-life costs. Things like decommissioning, disposal, recycling, site remediation.
Costs that might occur years after the last sale.
Years, even decades later, LCC forces you to consider those up front.
We generally break the product life cycle into phases, don't we?
Yeah, the typical model has 5 phases. Development, all costs, no revenue. Introduction, slow sales growth, high marketing costs. Growth, rapid sales increase, costs start to fall. Maturity, sales peak, intense competition, focus on efficiency. And finally, decline, sales fall, potential withdrawal.
And the key point for PM students is that costs and revenues are often wildly out of sync across these phases.
Exactly. During that development phase, costs are enormous. Revenue is zero. The product is a huge loss maker on paper. If management only looked at a short-term P&L, they'd panic and probably cancel potentially brilliant long-term projects. LCC provides that holistic cradle-to-grave view needed to justify those initial investments and losses.
So the strategic goal shifts from maximizing annual profit to maximizing the total return over the entire life cycle.
Precisely. And achieving that often requires getting managers aligned, achieving goal congruence by focusing on 2 key things: minimizing the time to market, getting revenue flowing sooner, and critically influencing costs when they're still flexible, which is usually back in the design stage. Most life cycle costs are locked in very early on.
Let's look at that example application from the notes. A planned product needed a target life cycle cost of $7 per unit to be viable, based on its expected selling price of $10.50 and required markup. But the initial estimate of its total life cycle cost was $7.80 per unit.
Right, so you have an 80-cent gap per unit over the entire projected life of, say, 50,000 units. That's a $40,000 total shortfall.
So management faces a strategic choice: kill the product, or find a way to bridge that $40,000 gap.
Exactly. And the example suggests one option. What if the company invests an additional $20,000 right now up front on more sophisticated design and engineering? That adds to the total life cycle cost initially.
But the hope is it saves much more later.
That's the gamble. They must be confident that this extra $20K design spend will reduce the downstream manufacturing cost per unit significantly enough to make the overall $7 target achievable. If the total non-manufacturing costs, R&D, design, marketing, disposal, etc., come to $110,000 over the life cycle,
which works out at $2.20 per unit on 50,000 units.
right, then the manufacturing cost per unit must fall from the initially estimated $5.60, $7.20, down to just $4.10, $7.20 to hit that overall $7 target.
Yeah.
LCC provides the framework to analyze whether that upfront $20,000 investment is likely to yield at least $40,000 in future manufacturing savings. It justifies strategic spending early to save more later. Hashtag 1.4, accounting for sustainability. EMA.
Okay, shifting gears slightly, but staying with this broader view of costs. In today's business world, sustainability and environmental responsibility aren't just nice-to-haves, they're becoming core management concerns, right?
Absolutely essential. Ignoring environmental impact is now a massive financial and reputational risk. That's where environmental management accounting, EMA, fits in. It's about identifying, measuring, and managing the organization's impact on the environment, particularly focusing on resource efficiency and waste.
Because failing to manage waste or pollution, it doesn't just harm the planet, it hits the bottom line.
Directly. There's a threefold negative financial impact managers have to account for. First, the obvious direct cost paying for wasted raw materials, energy consumed unnecessarily, effluent treatment, landfill charges, cleanup costs.
Second, the reputational hit.
Huge. Severe reputational damage if you're seen as a polluter. That affects customer loyalty, brand image, attracting talent, even investor confidence, it translates into lower sales and market share eventually.
And third, the regulators.
Potential fines or penalties for breaching environmental laws can be substantial. So, EMA is fundamentally about risk management as well as cost management.
So EME needs to track more than just the obvious waste disposal bill. It's broader than that.
Much broader. It involves tracking the cost of excess raw materials usage. Why are we generating so much scrap? It includes analyzing the financial impact of transport choices. Are greener options actually cheaper in the long run, considering fuel and potential carbon taxes? It requires detailed monitoring of water and energy consumption to spot inefficiencies and potential savings.
The source material mentions 4 main accounting methods or techniques used within EMA to force management focus onto these environmental costs. Can we quickly outline those?
Sure, conceptually. First, you've got inflow-outflow analysis. This is foundational. It's basically a mass balance approach, often in physical units first, kilograms, liters, kilowatt hours, and then monetized. You track everything coming in: materials, water, energy, and everything going out finished product, and crucially, all forms of waste: solid waste, emissions, wastewater.
The difference is the waste?
The difference highlights the physical quantity and potential cost of the waste stream, forcing you to quantify it.
Okay, what's next? Second, flow cost accounting. This builds on the inflow-outflow idea, but maps the costs onto the organizational structure. It typically divides resource flows into 3 categories: material, costs of raw materials, components; system, internal costs like handling, storage, quality control related to the flow; and delivery disposal, costs associated with getting the finished product out and dealing with any residual waste. It helps pinpoint where in the process waste and inefficiency are occurring. Third is life cycle costing, which we just discussed. But in the EMA context, it specifically ensures that those future environmentally driven costs, like product take-back obligations, recycling costs, or future carbon liabilities, are factored into the initial product design and investment appraisal.
Makes sense. And the fourth? Fourth is environmental activity-based costing. Just like regular ABC assigns overheads more accurately, environmental ABC specifically identifies environment-related costs, like running a wastewater treatment plant or managing hazardous waste disposal, and attributes them to the specific products or processes that cause those costs, rather than just smearing them across everything. It identifies the true environmental cost drivers.
It's fascinating how all these tools, ABC, target costing, LCC, EMA, are really pushing managers towards the same goal: getting better information to align short-term operational choices with long-term strategic goals, profitability, and now sustainability.
Exactly. They provide the visibility needed for smarter decisions.
Which brings us perfectly to part 2. Using this better information to make optimal choices, especially when resources are limited.
Right. This is the classic short-term decision problem. Optimization under scarcity. What do you do when demand for your products is higher than your capacity to produce them? Because one specific input, the key factor or limiting factor, is holding you back. It could be machine hours, skilled labor, a specific raw material.
The conventional approach, rooted in marginal costing, is called key factor analysis, right?
Correct. The principle is simple. You don't rank products based on their total contribution per unit. Instead, you rank them based on the contribution earned per unit of the scarce resource.
So if machine hours are the bottleneck, you calculate contribution per machine hour for each product.
Precisely. Using the pipe lake example from the notes. Product A generated $2.50 contribution per machine hour, while product B generated $4 per machine hour. So product B is the higher priority product.
And the optimal production plan.
You make as much of product D as you can first, using up machine hours. Then, with whatever hours are left, you make product A. That mix maximizes the total contribution, which was $55,000 in that example. It's straightforward, logical,
but
it relies entirely on the traditional marginal costing assumption that all costs, other than direct materials, are variable with production volume in the short term. Labor, factory overheads. It assumes they flex perfectly.
And modern manufacturing, especially with just-in-time JIT and high automation, kind of challenges that assumption, doesn't it? Leading to a different approach: throughput accounting, TA.
Exactly. TA emerged from the JIT philosophy, particularly Eli Goldratt's theory of constraints. It takes a much stricter view of short-run costs. Its core concept is this: in the very short term, the only truly variable cost is direct material cost.
So labor, overheads, they're treated as fixed.
In the short run, yes. TA bundles all their factory costs, labor, energy, rent, depreciation, supervision, into one lump sum called total factory costs, TFC, and treats it as fixed for decision-making purposes. The only cost that genuinely increases cash outflow purely because you made one more unit is the raw material that went into it. Inventory, by the way, should be minimized and valued only at this material cost under TA.
Okay, so if only material is variable, the focus shifts from contribution to something else.
Yes, it shifts to throughput. Throughput is defined as revenue minus direct material cost. That's the rate at which the system generates cash from sales.
And how do you rank products then?
You evaluate products based on the return per factory hour, which is throughput divided by the time the product spends on the key bottleneck resource, compared against the cost per factory hour, which is total factory costs divided by the total available hours on that bottleneck resource.
So return per hour versus cost per hour.
Exactly. The key decision rule is the TA ratio, return per factory hour divided by cost per factory hour. For a product to be even worth considering, its TA ratio must be greater than 1. If it's less than 1, you're spending more on running the factory per hour than you're generating in throughput from that product during that hour.
And you prioritize production based on the highest TA ratio.
Highest TA ratio first.
And this can actually change the ranking compared to the contribution method.
It often does. In that same PyPalk example, when reevaluated using TA, product A actually generated a higher throughput per hour, $8.50, than product B, $8. If the factory cost per hour was, say, $7.50, then product A's TA ratio was 1.1330, $7.50, while product B's was only 1.07, $8.7750.
So under TA, you'd make product A first, completely flipping the optimal mix derived from contribution analysis. Why the difference?
It's a philosophical difference about short-term cost behavior. TA prioritizes maximizing the rate of cash generation through the bottleneck, assuming that the fixed factory costs are unavoidable in the immediate short term anyway. Contribution analysis assumes other costs are avoidable.
It sounds like the whole TA system forces you to identify and obsess about the single biggest constraint in your process.
It absolutely does. Identifying the bottleneck resource is critical. As the Yamco example showed, you compare the capacity of each stage, pressing, stretching, rolling, and find the one with the lowest output potential. In their case, it was the pressing machine.
And that single bottleneck dictates everything.
It dictates the maximum output of the entire system. All TA calculations, return per factory hour, cost per factory hour. The TA ratio must be focused solely on the time spent on and the total time available on that specific bottleneck resource. Improving flow anywhere else doesn't increase overall output unless you first address the bottleneck.
Okay, key factor analysis and throughput accounting are great if you have just one limiting factor, one bottleneck. But what happens in reality when you often have 2, maybe 3 resources that are scarce at the same time? Perhaps you're short on skilled labor and a critical component.
Right. As soon as you have 2 or more constraints binding simultaneously, the simple ranking approach of key factor or TA breaks down. You can't just prioritize based on one resource anymore.
So that's where we need a more powerful mathematical tool.
Exactly. That's where we have to bring in linear programming, LP. LP is the structured mathematical technique for finding the absolute optimal production mix when you're faced with multiple resource constraints.
Okay, for the ACCA student facing an LP question, probably in Section C, what are the essential steps they need to execute perfectly?
There's a very defined 5-step process you have to follow. 1. Define your unknowns. Be crystal clear what your variables represent. Usually it's the quantity of each product to make, like S for standard chairs, E for executive chairs. 2. Formulate the constraints. This is crucial. You need to translate every single resource limitation into a mathematical inequality. If material is limited to 80 kilograms total, and standard chairs use 2 kilograms each, executive use 4 kilograms each, the construct is $2 plus 4 ELIC cup weight. You do this for every constraint: labor hours, material types, machine time, even maximum sales demand. 3. Formulate the objective function. What are you trying to achieve? Usually it's maximizing total contribution. So if standard contributes $6 and executive contributes $9, your objective is maximize $2, 6S plus 9 EK, a 4 downsers. Graph the constraints. This is the visual part. You plot each inequality constraint as a line on a graph with S on one axis, E on the other. The area on the graph that satisfies all constraints simultaneously is called the feasible region. Any point inside or on the boundary of this region is a possible production plan. 5. Find the optimum solution. Here's the key inside of LP. The optimal solution, the point that maximizes your objective function, will always lie at one of the vertices, quarter points, of the feasible region. You identify the potential vertices, usually by solving the simultaneous equations of the lines that intersect at each corner, calculate the contribution at each valid corner, and the one with the highest contribution is your optimal plan.
And in Peter's chair example, with constraints on material and labor, the feasible region was plotted, and the optimal point was found where the material constraint line intersected the labor constraint line.
Correct. Solving those two equations simultaneously gave the optimal production plan. Make 30 standard chairs and 5 executive chairs. Plugging those quantities back into the objective function, $2 6S plus 9E1, gave the maximum possible contribution of $225.
Okay, so finding that optimal point is the primary goal. But LP gives us more than just the production plan, right? It provides really valuable what-if information.
Absolutely. Once you have the optimal solution, the analysis moves to understanding the implications. Two key concepts here are slack and shadow prices.
Let's start with slack. What is that?
Slack represents spare capacity in any resource that is not fully used up at the optimal solution point. These are called non-binding constraints. In Peter's example, there was also a demand constraint they could sell at most 10 executive chairs. Since the optimal solution only involved making 5 executive chairs, there were $10.55 bar 70 few units of slack on the executive chair demand constraint.
So we had spare demand capacity for executive chairs.
Exactly.
Yeah.
But the material constraint, $2 plus 4E equals 81, and the labor constraint, $5 plus 60 equals plus 60 equals 181, were both met exactly at the optimal point, 35. They were binding constraints, meaning they had zero slack. We used up all the available material and all the available labor.
Okay, and that leads us to the really powerful concept, the shadow price, sometimes called the dual price.
Right. The shadow price is one of the most strategically important outputs of LP. It tells you the maximum extra premium you would be willing to pay for one additional unit of a scarce resource whose constraint is currently binding. It quantifies the value of relaxing a bottleneck by just 1 unit, 1 kilogram of material, 1 hour of labor.
So it tells you exactly what that scarce resource is worth to the business at the margin.
Precisely. In Peter's chair example, the calculations, which often involve resolving the LP or using matrix algebra, though exam questions might pry them, showed the shadow price for material was 1.125 cents per kilogram, and the shadow price for labor was $0.75 per hour.
How does a manager use those numbers in practice? Say someone offers to sell them more material or asks for overtime pay.
They become critical decision thresholds. If a supplier offers Peter an extra kilogram of material for an extra $1 above the normal price, Peter should immediately say yes, because that extra kilogram is worth up to 1.125 cents in additional contribution. He gains 8.125 cents by buying it.
But if the supplier asks for an extra $1.50,
he has to say no. Paying $1.50 for something that only generates 1.125 extra contribution makes the company worse off. Similarly, if the labor union asks for overtime pay at a premium of $1 per hour above the normal rate, Peter should refuse, because an extra hour of labor is only worth 75 cents in extra contribution at the margin. The shadow price sets the absolute ceiling on what you pay for more of that scarce resource. Hashtag 2.3 pricing decisions and market dynamics.
Okay, moving from optimizing production with scarce resources to setting the price in the marketplace. This is where internal cost information meets external market realities. What are the key forces influencing that pricing decision?
Fundamentally, price is usually influenced by a triangle of factors. Your own costs, what your competitors are charging, and what your customers are willing and able to pay. Demand.
Simple cost-plus strategies are often the starting point, aren't they? We touched on this earlier.
Yes, they're common because they're easy. But you need to be clear on the difference between full cost plus, where you calculate the total cost per unit, including absorbed fixed overheads, and add a percentage markup, and marginal cost plus, where you only mark up the variable or marginal cost.
And example 1 showed they can give quite different prices. Full cost plus 20% led to $33.60, while marginal cost plus 40% led to $32.20.
Exactly. Full cost plus gives you price stability and ensures all costs are covered if you hit your budgeted volume, but it ignores demand and can lead to uncompetitive prices. Marginal cost plus is more flexible and better for short-term decision-making, but you have to be careful to ensure the markup is sufficient to cover fixed costs in the long run. Both methods fundamentally ignore demand elasticity.
So, to find the theoretically optimal price that maximizes profit, we need to bring demand into the equation. The rule is to produce and sell up to the point where marginal revenue, MR, equals marginal cost, MC, right?
That's the golden rule from economics. You keep selling units as long as the revenue from the last unit sold, MR, is greater than the cost of producing that last unit, MC. Maximum profit occurs exactly where MR equals MC. Selling beyond that point means the extra units are costing more than they're bringing in, reducing total profit.
How does management find that MRMC point in practice?
Well, they can use a tabular approach, especially if the demand curve isn't a smooth line. The Kennedy Playa example showed this. You list different price points, estimate the quantity demanded at each price, calculate total revenue, PXQ and total cost, Then work out the marginal revenue and marginal cost for each step up in quantity. You find the quantity level where MR is closest to, and ideally just above, MC.
But for the ACCA exam, particularly in Section C, you often need the algebraic approach using the demand equation.
Yes, you absolutely do. You'll often be given or need to derive the linear price demand equation, which takes the form P equals ABQ. Here, P is price, Q is quantity demanded, A is the theoretical maximum price where demand is 0, and B is the gradient of the demand curve, change in price, change in quantity.
And the crucial bit is the related marginal revenue equation.
The key relationship you must know, and thankfully it's usually provided in the exam formula sheet, you don't need calculus to derive it, is that if P is ABQ, then MR equals a 2BQ. The MR curve has the same intercept A as the demand curve, but is twice as steep.
Okay, so you find A and B from the demand data, get the MR equation, you know your marginal cost, MC, often assumed constant per unit, set MR, MC, and solve for Q.
Exactly. Example 6 walk through this. Once they establish P is 0.00001 Q, they knew MR equals 12.0002 Q. Given a constant MC of $5 per unit, they set 120.0002 Q was 55. Solving that simple equation gave the optimal quantity. Q equals 57,500 units.
And then you plug that Q back into the price equation to find the optimal price.
Right. P equals 120.001,557,500 equals $62.50. So the profit maximizing strategy was to sell 57,500 units at $62.50 each, which resulted in the maximum possible profit of $3,206,250. This algebraic method is the only way to pinpoint the exact optimum price and quantity.
This whole calculation hinges on how sensitive customer demand is to changes in price. That brings us to price elasticity of demand, PED.
Yes, PED measures that sensitivity. It's calculated as the percentage change in quantity demanded divided by the percentage change in price.
And the value tells us.
If the absolute value of PED is greater than 1, demand is elastic. This means customers are very sensitive to price changes. A small price increase causes a large drop in demand. Think luxury goods or things with many substitutes. If PED is less than 1, demand is inelastic. Customers aren't very sensitive to price changes. You can increase the price quite a bit without losing much volume. Think necessities like gasoline or basic food items. If PED equals 1, it's unit elasticity.
And knowing the PED helps predict the impact of a price change on total revenue.
Critically, if demand is elastic, 1 increase in the price will decrease total revenue because the drop in quantity outweighs the price rise. If demand is inelastic, 1 increasing the price will increase total revenue. Example 3 showed how PED itself can change at different points on the demand curve. It was 32 at one price point, but only 10 at another, showing sensitivity isn't always constant.
Finally, on pricing, managers use various strategies depending on their goals and the market situation. Can we quickly list the common ones?
Sure, you've got penetration pricing, setting a low initial price to gain market share quickly, especially in a new market. Price skimming, setting a high initial price for innovative or exclusive products to capture maximum revenue from early adopters before competitors arrive. Think new tech gadgets. Product line pricing, setting prices across a range of related products, example, different models of cars or software versions. Complementary product pricing often involves a low price for the main product, like a printer or razor, but high margins on the necessary consumables, ink cartridges, blades. Also called captive product pricing. Price discrimination, charging different prices to different customer segments for the same product or service, where the price difference isn't justified by cost differences, e.g. student discounts, peak off, peak travel. Volume discounting, offering lower prices per unit for larger purchases.
So lots of strategic options beyond just cost plus or MRMC. Hashtag tag 2.4 short-term decision-making and relevance.
Okay, let's shift focus now to the absolute bedrock principle for almost all short-term management accounting decisions. The concept of relevance. When deciding between alternatives, we must ruthlessly filter out irrelevant information and focus only on the costs and revenues that differ between the options.
This sounds simple, but getting it right under exam pressure can be tough. Let's nail down the key terminology. What defines a relevant cost or revenue?
A relevant cost or revenue must meet 3 criteria. It must relate to the future, it must involve an incremental change, i.e., it only occurs if you choose a particular option, and it must involve cash flow.
Okay, future incremental cash flow. What about specific cost types we need to handle?
Right, let's break them down. Contribution, sales revenue minus variable costs, is almost always relevant because it directly measures the cash generated by an activity. Avoidable fixed costs, these are relevant. If shutting down a department saves $5,000 in supervisor salary that wouldn't otherwise be saved, that $5,000 is a relevant benefit of shutting down. Unavoidable fixed costs that continue regardless of the decision are irrelevant, sunk costs. These are costs already incurred or committed to. Think the historical purchase price of an asset or development costs already spent. They're always irrelevant to future decisions because you can't change the past. Ignore them completely. Relevant costs. This is just the umbrella term for future incremental cash flows arising directly from a decision. Opportunity cost. This is often the trickiest, but is absolutely critical. It's the value of the next best alternative foregone as a result of making a particular decision. If using a machine for Project A means you cannot use it for Project B, which would have generated $10,000 contribution, then that $10,000 loss contribution is an opportunity cost, and therefore a relevant cost, of choosing Project A.
Okay, that's the toolkit. Let's apply it to some classic scenarios. First up, shutdown problems. Deciding whether to close a loss-making department or product line.
Right. The Rooks-Bonds-Bishops example is perfect. The Wix division was showing an accounting loss of $2,000. The knee-jerk reaction might be to shut it down.
But you need to look at relevant costs.
Exactly. If you shut down Rooks, you lose the contribution it was making, which was $15,000. However, you only save $5,000 in fixed costs that were specific to Rooks, the avoidable fixed costs. The other $12,000 of fixed cost allocated to Rooks were unavoidable head office costs that would continue anyway.
So shutting down Rooks means losing $15K contribution, but only saving $5K costs.
Meaning the company's overall profit would fall by $10,000, $15K, $5K. So despite the accounting loss, Rooks should continue operating based on relevant costs.
But the decision flips if there's an opportunity cost. If closing Rooks frees up resources for something better.
Precisely. If the resources, machines, space, freed up by closing Rooks could be used to produce a new product, Crowners, which would generate an additional $20,000 in contribution, but incur $6,000 of new fixed costs.
So Crowners gives a net gain of $14,000, 20K of 6K.
Right. Now you compare the net cost of keeping Rooks running, which we found was $10,000 lower profit if shut, against the net benefit of replacing it with Crowners, $14,000 higher profit. The switch yields a net improvement of $4,000, 14K, 10K. In this scenario, you should shut down Rooks to make way for Crowners.
Okay, that shows the power opportunity cost. What about applying relevant costing to a one-off contract decision like the Parser Ltd example? That seemed to involve filtering out lots of irrelevant numbers.
Yes, special contract decisions are prime territory for relevant costing. The accountant in the Parser example had included all sorts of costs in their initial assessment, many of which were irrelevant. You have to go line by line.
Let's focus on the tricky ones. Materials and labor machine hours. How do you determine the relevant cost of materials already in inventory?
It depends entirely on what else you could do with those materials. If the materials are in regular use and you'd have to buy more to replace them if used on the contract, the relevant cost is the current replacement cost. If materials are obsolete but have some scrap value or could be sold externally, the relevant cost is the opportunity cost. The net realizable value, selling price less selling cost, you sacrifice by using them on the contract instead of selling them. If the materials are obsolete and have no alternative use and no scrap value, their relevant cost is zero, regardless of what you originally paid for them. That's a sunk cost.
So in the Parser Ltd case, the materials were obsolete but could be sold externally for $4.20 per kilogram.
Right, so the relevant cost wasn't the $34,000 original purchase price, sunk cost, but the $31,500, $4.20 of 7,500 kilograms of lost sales revenue, the opportunity cost of using them internally.
And what about the machine hours? The schedule included depreciation and absorbed fixed overheads.
Both are relevant. Depreciation is an accounting allocation of a sunk cost. Absorbed fixed overheads are usually irrelevant unless the contract causes total fixed overheads to incrementally increase. The relevant cost of using the machine hours was twofold. 1. The incremental variable overheads incurred by running the machine, like power, which was $4 per hour. 2. The opportunity cost. Using the machine for this contract meant Parser Ltd had to displace work on another product that generated contribution. The loss contribution, $10,000, was an opportunity cost of taking on the new contract.
So the total relevant cost for the 2,000 machine hours was the variable overheads, 4 by 2,000 equals $8,000, plus the lost contribution, $10,000 from displacement, plus another $4,000 from diverting other work, totaling $22,000.
That's the logic, though the example's calculation seems to focus just on the displacement. The key is identifying the variable cost plus any contribution foregone. You have to meticulously filter out sunk costs and non-incremental fixed costs to arrive at the true relevant cost for the decision.
Okay, one more classic relevant cost scenario. Make or buy decisions. Should we produce a component internally or outsource it?
The basic rule is simple. Make it internally if the incremental cost of making is less than the external buying-in price. You compare the supplier's price to your relevant cost of making, which includes direct materials, direct labor, variable overheads, and any incremental fixed costs specifically caused by making that component.
But what if we have limited capacity, like a scarce resource, and we can't make all the components we need?
Then it becomes a key factor problem again. You can't just compare cost to buy price for each component individually. Instead, you need to calculate the saving per unit of the scarce resource achieved by making each component internally, buying price incremental making cost.
And you prioritize making the components that give the biggest saving per unit of the limiting factor.
Exactly. Using the example, if material B was scarce, and making product X saved $2 per kilogram of material B, while making product Y saved $2.50 per kilogram of material B, you'd prioritize using your limited material B to make product Y first, because that maximizes the benefit derived from each scarce kilogram. You'd only make X if you still had material B left over after satisfying the requirement for Y. Hashtag 2.5, handling risk and uncertainty.
So far, all these decisions, LP, relevant costing, have assumed we know the future outcomes, the costs, the demands. But reality is messy. We have to deal with risk and uncertainty. What's the difference?
It's a crucial distinction. Risk exists when we can identify several possible future outcomes for a decision, and crucially, we can assign probabilities to each of those outcomes, usually based on past experience or data. We don't know which outcome will happen, but we know the odds. Think rolling a dice, the possible outcomes, 1 to 6, and the probability of each stake.
And
Uncertainty exists when we might be able to identify possible outcomes, but we cannot assign objective probabilities to them. The future is essentially unknown, perhaps because it's a completely novel situation with no past data to rely on. Think launching a radically new technology, you just don't know how the market will react.
okay, so when we can assign probabilities, i.e., we're dealing with risk, how do different managers make decisions? Their attitudes towards risk matter, right?
Absolutely. Different risk preferences lead to different decision criteria. The notes use John's factory contract example to illustrate 4 main approaches using a payoff table, which shows the profit outcome for each decision under different possible demand scenarios.
First, the optimist.
The risk seeker, who uses the maximax criterion. They look down the maximum possible profit column for each decision option and choose the option with the highest possible best outcome. They focus purely on the upside potential, ignoring the downsides. In the example, they choose the 300-unit contract because it offered the highest single potential profit, $5,400.
Second, the pessimist.
The risk avoider, who uses the maximum criterion. They look at the worst possible outcome for each decision option and then choose the option whose worst outcome is the least bad, the maximum of the minimums. They want the best guaranteed minimum result. In the example, they'd choose the 800-unit contract because its worst possible outcome was a profit of $4,400, which was better than the worst outcomes of the other options.
Third, the pragmatist or statistician.
The risk-neutral decision maker, who uses expected value, EV. This is the purely statistical approach. You multiply the profit outcome for each scenario by its probability, sum these up for each decision option, and choose the option with the highest overall weighted average or expected value. In the example, the 700-unit contract had the highest EV of $4,500.
And the fourth one, which seems a bit more complex, mini-max regret.
Right. This approach focuses on minimizing potential regret or opportunity loss. For each possible future scenario, the example demand level, you first figure out what the best possible profit would have been in that scenario. Then for each decision you could have made, you calculate the regret, the difference between the profit you got and the best profit you could have gotten in that scenario.
So it's about how much profit you missed out on.
Exactly. Then, for each decision option, you identify the maximum regret you could possibly experience across all scenarios. Finally, you choose the decision option that has the lowest maximum regret, minimizing the maximum possible ouch. In the example, this criterion also pointed to the 700-unit contract, as its maximum possible regret was only $800 lower than the maximum regrets for the other options.
It's really interesting that different perfectly logical criteria can lead to different optimal decisions depending entirely on the manager's attitude to risk.
Absolutely. There's often no single right answer. It depends on the risk profile.
Related to probabilities and EV, there's the concept of the value of information. How much should we be willing to pay for better forecasts or market research?
The value of perfect information, VPI, gives us the theoretical upper limit. You calculate the expected profit with perfect knowledge, assuming you could always choose the best action for whatever scenario actually occurs, and subtract the expected profit without perfect knowledge, which is just the highest EV you could get based on current probabilities.
So in John's example, the EV with perfect knowledge was calculated as $4,800. The best EV without perfect knowledge was $4,500 from choosing the 700-unit contract.
Right, so the VPI is $4,800, $4,500 equals $300. This means John should be willing to pay up to $300 for a perfectly accurate market forecast. Anything more than that, and the information isn't worth its cost.
And when decisions happen in sequence, maybe with research happening in between, we use decision trees.
Exactly. Decision trees are excellent for visually mapping out problems with multiple stages, decisions, and probabilistic outcomes. You draw the tree starting with the initial decision, branching out for possible outcomes with probabilities, leading to further decisions or final payoffs.
And the key is to evaluate the tree backwards.
Yes, you always roll back the tree from right to left. At chance nodes, circles, you calculate the expected value. At decision nodes, squares, you choose the branch with the highest EV, effectively pruning the suboptimal branches. This process works back to the initial decision point, telling you the optimal strategy and its overall expected value, even accounting for imperfect market research, as shown in the combi pick example.
It really brings together probability, expected value, and sequential choices. Okay, this whole section on optimizing decisions under constraints and risk provides the analytical engine for performance management. Let's move into part 3, the more formal systems of planning, control, and analyzing what actually happened.
Right, so budgeting. It's the formal, usually annual process that translates the organization's strategic plans into quantitative targets. It's not just about number crunching, though. It serves multiple crucial functions.
Like what? What are the core benefits we should remember?
The textbook ones are often summarized with acronyms like PRMCE or similar, but fundamentally they are planning, forcing managers to think ahead; resource allocation, deciding who gets what; coordination, ensuring different departments' plans fit together; control, providing a benchmark to measure actual performance against; motivation, giving managers targets to aim for; and evaluation, assessing managerial performance.
Okay, when a company starts putting its budget together, where does it begin? There's usually one key factor that limits everything else, right?
Yes, that's the principal budget factor, PBF. It's the constraint that limits the overall level of activity for the budget period. For most companies, this is sales demand. If you can only sell 10,000 units, there's no prank budgeting to produce 20,000.
So the sales budget usually comes first.
Typically, yes. But the PBF could be something else. If you're severely constrained by the availability of a critical raw material, or skilled labor, or machine capacity, then that becomes the starting point, and the production-related budgets would be prepared first, dictating how much you can sell. Identifying the PBF is step one.
And then the budgets flow in a logical sequence, like dominoes.
Exactly. It's an interlinked process. Using the XYZ company example, if sales is the PBF, you start with the sales budget. How many units at what price? That dictates the production budget, units to make health sales, plus closing inventory, opening inventory. The production budget drives the material usage budget, how much material needed for production, which in turn drives the material purchases budget, usage plus closing opening inventory. Similarly, the production budget drives the labor budget, overhead budgets, and eventually they all feed into the budgeted financial statements, P&L, balance sheet, cash flow.
Understanding that logical flow seems key for exam questions that ask you to prepare functional budgets.
Absolutely. Now, when it comes to using budgets for control, comparing budgeted figures to actual results, we need to be careful about which budget we use for comparison.
You mean fixed versus flexed budgets?
Precisely. The fixed budget is the original budget prepared at the start of the period based on the planned level of activity. But comparing actual results at whatever activity level was actually achieved to this fixed budget is often meaningless if the actual activity level was different.
Because the difference could just be due to volume changes, not efficiency.
Exactly. That's why we need the flex budget. A flex budget takes the original budget's cost structure, variable cost per unit, fixed costs, but adjusts the volume to the actual activity level achieved.
So using example 2, the original budget was for 10,000 units, but they actually produced 12,000 units. Comparing actual cost for 12,000 units to the fixed budget for 10,000 units is apples and oranges.
Right. You need to flex the budget to 12,000 units. 12,000 x variable cost per unit plus original fixed costs. Then, comparing the actual cost for 12,000 units to the flex budget for 12,000 units allows you to isolate the true spending and efficiency variances, removing the distortion caused purely by the volume difference. Flexing is essential for meaningful variance analysis.
We should also mention rolling budgets.
Yes, instead of a fixed annual budget, a rolling budget is continuously updated. For example, you might have a 12-month budget, and at the end of each month or quarter, you review performance, add a new month quarter to the end, and revise the figures for the remaining period. It keeps the budget more current and forward-looking, especially dynamic environments.
Okay, what about the different methods of setting the budget figures in the first place? Incremental is common, but maybe not always best.
Incremental budgeting is definitely the most common method. You take last year's actual results, or budget, and simply adjust it for expected inflation, known changes, like price increases, and maybe a desired growth percentage. It's quick, easy, and stable.
But the big risk.
The huge risk is that it just perpetuates past inefficiencies. If a department was overstaffed or wasteful last year, simply adding 3% for inflation bakes that waste into the new budget. It doesn't encourage a fundamental review of activities.
Which leads to the alternative, zero-based budgeting, ZBB.
Right. ZBB is philosophically the opposite. It starts from a baseline of 0 for every single activity. Managers have to justify every item of expenditure from scratch, explaining why the activity is needed at all and what resources are required to perform it effectively. Activities are often broken down into decision packages with different service funding levels.
It sounds much more rigorous.
Far more rigorous. ZBB forces a thorough review of efficiency and effectiveness, but the downside is equally massive. It's incredibly time-consuming, requires intensive management effort, can be politically charged as managers defend their turf, and is often impractical to apply to the entire organization every single year. Usually, companies might apply ZBB to specific departments or cost centers on a rotating basis.
This brings us neatly to the behavioral aspects of budgeting. It's not just a technical exercise. It's about people and motivation. Goal congruence is key here, right?
Absolutely critical. We need the budget process to encourage managers to make decisions that are in the best interest of the company as a whole. Goal congruence, not just optimizing their own department's results, potentially at the expense of others. Dysfunctional behavior.
How does participation affect this? Top-down versus bottom-up?
Participation plays a huge role. Top-down budgets, where senior management simply imposes targets on lower-level managers, can be quick, but often lead to resentment, lack of ownership, and gaming the system because managers feel the targets are unfair or unrealistic.
Whereas bottom-up or participative budgeting, where managers are involved in setting their own targets,
generally leads to greater acceptance, commitment, and motivation. Managers feel the targets are more realistic and achievable because they had input. However, the risk here is budgetary slack managers might try to negotiate targets that are too easy to achieve or overestimate costs to make their performance look better. Senior management still needs to review and challenge participative budgets to ensure they are sufficiently stretching.
and the nature of the targets themselves. What makes a good budget target?
Research suggests ideal targets should be challenging, but perceived as attainable with reasonable effort, maybe slightly above what's expected under normal conditions. Crucially, they must be agreed upon in advance, they need to be measurable, and very importantly, they should relate to factors that are controllable by the manager being assessed. Holding someone accountable for costs they have no influence over, like those head office recharges we mentioned, is a recipe for demotivation.
Finally, on budgeting, we should touch on the beyond budgeting movement. There's been criticism of traditional annual budgeting recently.
Yes, quite a lot. Critics argue the traditional annual budget process is too time-consuming, becomes outdated quickly in fast-moving markets, is too rigid and stifles initiative, encourages dysfunctional use-it-or-lose-it spending at year-end, and often focuses too much on internal targets rather than external competitiveness.
So, beyond budgeting proposes.
It's more a set of principles than a single method. It advocates for things like more adaptive management processes, using rolling forecasts instead of fixed annual budgets, empowering frontline managers, measuring success based on relative performance against external benchmarks or competitors rather than just hitting an internal budget number, and fostering a more flexible, performance-driven culture. It's about being more agile and market-focused. Hashtag 3.2 Analytical Techniques for Forecasting, Chapter 12.
Okay, accurate budgeting relies on accurate forecasting of costs and revenues. Let's look at a couple of key analytical techniques used for this. First, the simple high-low method. What's that used for?
The high-low method is a quick and easy way to separate a semi-variable cost, one that has both a fixed and a variable component, like a phone bill with a fixed line rental plus variable call charges, into its fixed and variable parts. It assumes a linear relationship between cost and activity level.
How does it work?
You take two data points, the total cost at the highest activity level and the total cost at the lowest activity level from a relevant period. You then calculate the change in cost between these 2 points and divide it by the change in activity level. That gives you the estimated variable cost per unit of activity.
So using example 1, highest cost was $85,000 at 700 units, lowest was $40,000 at 100 units.
Right. Change in cost is $45,000, $85K, $40K. Change in activity is 600 units, 700 unit. So the variable cost per unit is $45,000, 600 units equals $75 per unit.
And then you find the fixed cost.
You plug the variable cost back into either the high or low data point. At the high level, total cost $85,000, fixed cost plus variable cost, 700 units, 75 unit. So $85,000 fixed cost plus $52,500. Therefore, the fixed cost must be $32,500 per month. You can check this using the low point too. You should get the same answer. It's simple, but relies on only 2 data points and assumes linearity.
Okay, a much more specialized but vital forecasting technique, especially for new products or processes, is the learning curve.
Yes, the learning curve effect or experience curve is essential for forecasting labor costs when tasks are new, complex, and highly repetitive. It recognizes that people get faster and more efficient at doing a task as they gain experience.
What's the underlying theory?
The theory states that every time the cumulative output doubles, the cumulative average time per unit falls to a fixed percentage of the previous average time. That fixed percentage is the learning rate.
So if the very first unit takes 100 hours to make and the learning rate is 80%?
Then the average time for the first 2 units will be 80% of 100 hours, which is 80 hours per unit. This means the total time for 2 units is 160 hours. Since the first took 100, the second unit must have only taken 60 hours. 160, 100.
And the average time for the first 4 units?
Would be 80% of 80 hours equals 64 hours per unit,
Wow.
total 256 hours. And for the first 8 units, the average would be 80% of 64 hours equals 51.2 hours per unit, total 409.6 hours. The average time keeps falling, but at a decreasing rate.
Are there specific conditions where the learning curve applies? It doesn't work for everything, right?
No, definitely not. The conditions need to be right. The task must have a significant manual element and be fairly complex and repetitive. It usually applies only in the early stages of production. The learning effect eventually tails off. There needs to be continuity in production. Long breaks can cause workers to forget the learning. The workforce needs to be reasonably stable and motivated to learn.
Okay, there's a formula involved which looks a bit intimidating. Y is XB, HB.
It does. But let's break it down. Y is the cumulative average time per unit for X units. A is the time taken for the very first unit. X is the cumulative number of units produced. B is the index of learning, which is calculated from the learning rate, LR, as Y dollar log LR, log 22. Thankfully, B is often given, or you use logarithms or the formula sheet in the exam.
So how do we use this formula? Say example 2 asks for the total time for the second, third, and fourth units with a 10 hours and LR 90%.
Okay, first you need B. If LR is 0.9, then B yields log 0.9, log 2 and actual 0.152. To find the time for units 2, 3, and 4, you first calculate the total time for 4 units using the formula for Y, average time, and multiplying by X. To find the time for units 2, 3, and 4, you first calculate the total time for 4 units using the formula for Y, average time, and multiplying by X. Total time for 4 units, 4 times Y, 4 times A times 4B equals 4 times 10 times 4.152, 10. To find the time for units 2, 3, and 4, you first calculate the total time for 4 units using the formula for Y, average time, and multiplying by X. Then you subtract the time taken for the first unit, which is A equals 10 hours. To find the time for units 2, 3, and 4, you first calculate the total time for 4 units using the formula for Y, average time, and multiplying by X. So the time for units 2, 3, and 4 combined is approximately 35.110 equals 25.1 hours. To find the time for units 2, 3, and 4, you first calculate the total time for 4 units using the formula for Y, average time, and multiplying by X. You often have to calculate the time for a batch of units, which involves finding the total time up to the end of the batch and subtracting the total time up to the start of the batch.
And the learning doesn't go on forever. Eventually you reach a steady state.
Exactly. At some point, the rate of learning becomes negligible, and the time taken for each subsequent unit becomes constant. This is the steady state. If, as in example 3, the learning effect is expected to cease after the 30th batch has been completed.
How do you budget for batches after the 30th?
You need to calculate the actual time taken for the 30th batch itself. You do this by finding the total time for 30 batches using the formula and subtracting the total time for 29 batches. Let's say this calculation shows the 30th batch took 70 hours.
Okay.
Then the assumption is that the 31st, 32nd, and all subsequent batches will also take 70 hours each. The learning is stopped. So your budget for labor time from batch 31 onwards would be based on this steady state time of 70 hours per batch. Forgetting to account for the steady state is a common mistake. Hashtag TAG 3.3 Standard Costing and Performance Diagnosis, chapters 13 and 14.
Okay, once production is underway, we need to control costs and performance. This brings us to standard costing. What's the fundamental purpose of setting standards?
Standard costing provides the essential benchmark or yardstick against which actual performance can be measured. The standard cost is the planned or expected cost of producing one unit of output or performing an activity. Comparing actual costs to these standards generates variances, which highlight areas where performance has deviated from the plan, prompting investigation and potential corrective action. It's the cornerstone of budgetary control.
And there are different types of standards, depending on how demanding they are.
Yes, we generally distinguish between ideal standards, based on perfect operating conditions, no waste, no breakdowns, maximum efficiency. They're unattainable in practice, but can be used to highlight potential long-term improvement goals. Attainable, or expected standards, based on efficient, but not perfect, operating conditions. They allow for normal levels of waste, downtime, and inefficiency. These are the standards typically used for routine variance reporting and control. Current standards. Standards based on current working practices and resource prices. They reflect the reality of the current situation and are often used for performance appraisal, as they represent what should be achievable right now. Basic standards. Older standards kept unchanged over long periods, used mainly to show long-term trends rather than for current control.
So for routine control, we're usually using attainable expected standards. The process starts by calculating the overall variances, right? Comparing actual results to the flexed budget.
Yes, example 1 in Chapter 13 shows this. You calculate the total variance for materials, labor, variable overheads, fixed overheads, and sales. But simply knowing you have, say, an adverse total material variance isn't very helpful for management action.
You need to break it down further.
Absolutely. That total variance needs to be analyzed into its component parts to understand why it occurred. For materials, we break the total variance into materials price variance. Did we pay more or less than the standard price per kiloglitter? Actual QD purchased X, standard price, actual price. Materials usage variance. Did we use more or less material than allowed for the actual production achieved? Standard price, standard QD for actual production, actual QD used.
And similar breakdowns for labor, rate and efficiency variances, plus idle time variance if applicable, variable overheads, expenditure and efficiency, and fixed overheads, expenditure and volume.
Correct. And the crucial point, emphasized by example 4, is that just calculating these variances is only half the job. The real skill lies in interpretation and suggesting potential management action. An adverse material price variance needs investigation. Was it poor purchasing? An unavoidable market increase? A favorable usage variance? Was it better efficiency? Or using lower quality material that might cause problems later? Calculation without diagnosis is pointless.
Okay, now let's dive into the really advanced variance analysis needed for PM mastery. First, planning and operational variances. What's the problem with traditional variances that this breakdown tries to solve?
The fundamental flaw in traditional variance analysis is that it lumps together deviations caused by faulty planning or external factors with deviations caused by poor operational execution.
Yeah.
It doesn't distinguish between things the manager couldn't control and things they should have controlled.
Give me an example.
Okay, imagine the standard price for a material was set at $10 grams in the original budget. But halfway through the year, due to a global shortage, the market price permanently jumps to 12 kilograms, completely outside the purchasing manager's control. The traditional price variance will just show a massive adverse variance based on the $10 standard.
Which seems unfair to the manager.
Totally unfair and demotivating. The planning and operational variance approach fixes this. It introduces a revised budget, sometimes called an ex post or after the event standard, that reflects the realistic conditions that should have been achievable given what actually happened externally. In our example, the revised standard price might be 12 kilograms.
So how does the variance breakdown work then?
You calculate 2 separate variances. 1, planning variance. This compares the original budget standard to the revised budget standard. It measures the impact of the faulty planning or the uncontrollable external event. Original standard price, $10, revised in standard price. $12 gives a $2 adverse planning variance per kg. This part is generally not the operational manager's responsibility. 2, operational variance. This compares the actual performance to the revised budget standard. It measures how well the manager performed against a realistic, achievable target given the circumstances. If the manager actually paid $12.50 kilograms, the operational variance is 0.50 cents adverse per kilogram compared to the revised $12 standard. This variance is controllable and worth investigating.
So it separates blame for external shocks from blame for internal inefficiency.
Exactly. Example 1 in Chapter 14 illustrates this breakdown clearly for both material price and material usage variances. For example, if a new, less efficient material had to be used due to supply issues, that would create a planning usage variance, while waste above that revised standard would be an operational usage variance.
Okay, that's one type of advanced variance. What about mix and yield variances? When do these apply?
Mix and yield variances are needed when you have substitutable inputs in a process. This most commonly applies to materials, for example, using different grades of flour to make bread or different types of metal in an alloy, but can also apply to labor, using different skill grades or even sales, selling different products in a range.
And the problem is that the standard usage or efficiency variance can be misleading if the mix changes.
Precisely. Imagine your standard mix is 50% cheap material A and 50% expensive material B. If the manager decides to use 7% cheap A and only 30% expensive B, the overall material cost might go down, a seemingly favorable outcome. However, if this non-standard mix is less effective and results in lower overall output or higher wastage, the traditional usage variance might not capture the full picture.
So we split the total usage quantity variance into two parts.
Yes. We break the total materials usage variance into 1. Mix variance. This measures the cost impact of using a different proportion or mix of materials compared to the standard mix, valued at the standard prices. Did using more of the cheaper material save money, or did using more of the expensive one cost more, assuming the total quantity used was standard? 2. Yield variance. This measures the efficiency of the overall output. Did we get the expected total output, yield, from the actual total quantity of input used, regardless of mix? Or did we get less output, adverse yield, or more output, favorable yield, than expected from the inputs consumed? This is valued at the standard cost of the standard mix.
Example 3 showed a total materials usage variance of $300 adverse, but the breakdown.
The breakdown revealed a favorable mix variance of $233 because they used more of the cheaper material, saving money.
Yeah.
But an adverse yield variance of $533 because the overall process was inefficient, producing less output than expected from the total materials put in. Net effect, $300 adverse.
So without that breakdown, management would miss the fact that while the mix change was good financially, the underlying process efficiency was actually quite poor.
Exactly. It gives much deeper insight into why the usage variance occurred.
And finally, we can apply these variance principles even within an ABC system.
Yes, absolutely. If you're using activity-based costing, you can calculate variances for your activity cost centers. For example, for the dispatch activity driven by the number of orders, you could calculate an expenditure variance. Did the actual cost of running the dispatch department differ from the budgeted cost after flexing for the actual number of orders? An efficiency variance. Did the team handle more or fewer dispatch orders than expected for the hours worked or resources consumed? An efficiency variance. Variances can be applied to cost drivers just as easily as to direct materials or labor.
This detailed variance analysis really turns performance measurement from just scorekeeping into a diagnostic tool for control and improvement.
That's the goal. Actionable insights, not just numbers.
Okay, moving towards broader performance assessment. Often the starting point for diagnosis, especially in for-profit companies, is analyzing the financial statements using ratio analysis.
Yes, ratios are essential tools for interpreting financial data. They allow you to compare performance over time, trend analysis, compare against competitors or industry averages, cross-sectional analysis, and identify potential strengths and weaknesses.
For the PM exam, students need to know the key categories and the formulas cold, right?
Absolutely. You need to be able to calculate and interpret ratios from the main categories. Profitability ratios. How successful is the company at generating profit? Key ones are profitability ratios, gross profit revenue, showing basic trading profitability. Profitability ratios, net profit margin, profit before interest and tax revenue, or profit after tax revenue, be clear which, showing overall profitability after overheads. Return on capital employed, ROCE, this is a fundamental measure. Profit before interest and tax. Total assets less current liabilities or equity plus debt. It shows how effectively the company is using its long-term funds to generate profit. And remember, ROCE can be broken down. ROCE equals asset turnover, as net profit margin. Asset turnover, revenue capital employed, measures how efficiently assets are used to generate sales. Liquidity ratios, can the company meet its short-term debts? Liquidity ratios, current ratio,
current assets, current liabilities, the classic measure. Liquidity ratios, quick ratio or asset test, current assets inventory, current liabilities, a tougher test, excluding potentially hard to sell inventory. Related efficiency ratios include
Inventory days, receivables days, how long to collect cash from customers, and payables days, how long the company takes to pay its suppliers. These make up the cash conversion cycle. Gearing ratios, how risky is the company's financial structure? How reliant is it on debt? Gearing ratios. Gearing ratio typically measures long-term debt, shareholders' funds plus long-term debt, or sometimes debt equity. Higher gearing means higher financial risks, but potentially higher returns to shareholders if things go well.
Calculating them is one thing, but interpretation is key. And there are limitations to ratio analyses, aren't there?
Definitely. Ratios are almost meaningless in isolation. They must be compared to previous years, to budgets, to competitors, to provide context.
And the underlying numbers can be problematic.
Yes. Statement of financial position figures used in ROCE, liquidity gearing, are just a snapshot at one specific point in time, the year end. They might not be representative of the situation during the rest of the year. For example, a company might deliberately pay off suppliers just before year end to make its liquidity ratios look better, window dressing. Or a big seasonal inventory buildup could distort inventory days. You have to be aware of these potential distortions. Also, different accounting policies between companies can make comparisons difficult. Hashtag 4.2 Divisional Performance and Goal Congruence, Chapter 17.
As companies get bigger, they often decentralize, creating divisions or business units. This gives local managers more autonomy, which can be good for motivation and responsiveness, but it creates a control problem for head office, right? How do you ensure these autonomous managers are acting in the best interest of the whole company?
That's the central challenge. Ensuring goal congruence. You need performance measurement systems for these divisions that motivate the divisional managers to make decisions that benefit the overall group, not just their own division's reported results, especially if that harms another part of the company.
A key principle here is controllability, isn't it? Managers should only be judged on what they can actually influence.
Absolutely fundamental. When assessing a divisional manager's performance based on profit, you should ideally focus on controllable profit. This means excluding costs that are incurred centrally, like head office administration fees or central R&D costs, and then arbitrarily allocated or apportioned to the divisions. If the manager can't control a cost, holding them responsible for it is unfair and demotivating.
Okay, now what if the division isn't just a cost center or profit center, but an investment center, meaning the manager also has authority over investments in assets within their division? How do we measure performance then?
When the manager controls the investment base, simply looking at controllable profit isn't enough. You need to relate that profit to the amount of capital invested to generate it. The two main methods for doing this are return on investment, ROI, and residual income, ROI.
Let's start with ROI. How is it calculated and what's the issue?
ROI is conceptually simple. ROI, controllable divisional profit, controlled divisional investment, X 100%. It measures the percentage return generated on the assets employed by the division. It's widely used and easily understood.
But it can lead to dysfunctional decisions, the conflict you mentioned earlier.
Yes, this is the classic problem with ROI. It can lead to a rejection of perfectly good projects that are beneficial for the company as a whole. The source examples illustrate this perfectly.
Walk us through that conflict again.
Okay, imagine the company has a group target ROI of, say, 15%. A division currently earns an ROI of 16.4%.
Yeah.
Now, a new investment opportunity comes along for that division, which is expected to yield a return of 16%.
So 16% is above the company's 15% target. The company wants this project.
Exactly. It's a good project for the group. But what happens if the divisional manager accepts it? Their existing high ROI, 16.4%, will be diluted by adding this new project at only 16%. The division's new overall ROI might fall to, say, 16.3%.
So accepting a project that's good for the company makes the manager's own performance metric, divisional ROI, look worse.
Precisely. So the manager, motivated by maximizing their divisional ROI, has an incentive to reject the 16% project, even though it exceeds the company's target. That's a clear failure of goal congruence caused by using ROI as the performance measure.
And residual income ROI is designed to solve this problem.
Theoretically, yes. RI measures the division's profit after deducting a notional charge for the capital invested in the division. The formula is RI, controllable divisional profit, controllable divisional investment x imputed interest rate. That imputed interest rate is usually the company's target rate of return or cost of capital, example, the 15% from our example.
How does this avoid the ROI conflict?
RI measures absolute profit generated above the required return on investment, not a percentage. Therefore, any project that earns a return greater than the imputed interest rate will generate a positive RI and will increase the division's total RI.
So in our example, the 16% project earns more than the 15% imputed interest charge.
Yes. So it would generate positive RI. Accepting it would increase the division's total RI. Therefore, the manager, motivated to maximize RI, would accept the 16% project. RI aligns the manager's interest with the company's interest in accepting all projects that exceed the minimum required return. That's why RI is considered theoretically superior for promoting goal congruence in investment centers. Hashtag 4.3 transfer pricing. Related to divisional performance is the issue of transfer pricing. This arises when one division of a company supplies goods or services to another division within the same company. The transfer price is the internal price charged for that transaction.
Why do companies need transfer prices at all? Why not just transfer at cost or even for free?
Because if transfers happened at zero price, the supplying division would show no revenue for that work and would look terribly unprofitable, while the receiving division would get free inputs and look artificially profitable. To maintain meaningful divisional profit accountability and evaluate performance fairly, you need a transfer price that reflects the economic value exchanged.
Okay, but setting that price is tricky. We saw earlier that simple cost plus transfer prices, like variable cost plus 20%, can cause problems.
Big problems. Example 3 showed a scenario where Division A can make a component for $10, variable cost. Division B could buy it externally for $15. A cost plus 20% policy would mean A charges B $12. $10 plus 20%. That seems okay.
But what if Division A has limited capacity and could use that capacity to make a different product to sell externally for a contribution of $4?
Now the situation changes. A's opportunity cost of supplying internally is the $10 variable cost, plus the $4 loss contribution equal $14. If head office forces them to transfer at $12, cost plus, A loses money on the deal and will resist it. If B buys externally at $15, the company as a whole is $1 worse off than if the transfer happened at a price between $14 and $15. The rigid cost-plus policy fails to achieve goal congruence and leads to a suboptimal outcome for the group.
So to ensure the transfer price leads to the right decisions for the company overall, we need a more logical approach, often called the range rule or general guideline.
It's exactly. The ideal transfer price should motivate both managers to do what's best for the company. The rule provides a floor and a ceiling for negotiation. The minimum transfer price, from the supplier's perspective, should be marginal cost of the supplying division plus any opportunity cost incurred by the supplier due to the transfer. Opportunity cost only arises if the supplier is operating at full capacity and has to give up profitable external sales to supply internally. If they have spare capacity, the opportunity cost is zero, and the minimum TP is just marginal cost. The maximum transfer price, from the buyer's perspective, should be the lower of. The maximum transfer price from the buyer's perspective should be the lower of the external purchase price, what the buyer would have to pay an outside supplier. The maximum transfer price from the buyer's perspective should be the lower of. Or, if the buyer processes the item further and sells it on, the net marginal revenue to the buying division, which is final selling price, minus the buyer's own further processing costs. The buyer won't pay more than the item is worth to them.
So a transfer price negotiated anywhere between this minimum supplier's floor and maximum buyer ceiling should lead to goal congruent decisions.
In theory, yes. If such a range exists, a transfer is beneficial to the company, and a price within the range allows both divisions to share the benefit. The examples 4 through 7 show how this range changes depending on whether the supplier has spare capacity, min TP plus MC, or is at full capacity, min TP equals MC plus opportunity cost, and whether an external market exists for the buyer. Understanding how capacity and external markets affect the minimum and maximum price is crucial. Hashtag 4.4, Non-Financial Performance and Information, Chapter 16, 1922.
We spent a lot of time on financial metrics like ROI, RIY, variances, but effective performance management isn't just about the financials, is it? Especially in service industries or not-for-profit organizations.
Absolutely not. Relying solely on financial measures can give a very distorted picture and can even encourage dysfunctional behavior, like cutting quality or R&D to boost short-term profits. We need non-financial performance indicators, NFPIs, to provide a more balanced view.
This is where the balanced scorecard comes in.
Yes, Kaplan Norton's balanced scorecard is the most famous framework for integrating non-financial measures. It forces management to consider performance from 4 crucial perspectives, arguing that success in the non-financial areas drives future financial success.
What are the four perspectives?
They are: 1. Financial perspective. How do we look to our shareholders? This includes the traditional financial measures like profitability, ROCE, profit margin, sales growth, cash flow. 2. Customer perspective. How do our customers see us? Measures here focus on customer satisfaction, loyalty, market share, on-time delivery performance, number of complaints, results from customer surveys. 3. Internal business process perspective. What must we excel at internally? This looks at the efficiency and effectiveness of key processes, things like process cycle time, unit cost analysis, quality metrics, defect rates, waste reduction, capacity utilization. 4. Learning and growth perspective. How can we continue to improve and create future value? This focuses on the organization's ability to innovate and grow measures like employee satisfaction and retention, training hours, number of new products introduced, time to market for new products, investment in R&D.
So the idea is to have specific measurable targets across all four areas to get a holistic view of performance.
Exactly, a balanced view.
Now, in the not-for-profit, NFP sector, charities, government bodies, hospitals, schools, profit isn't the main objective. How do they measure performance?
In the NFP sector, the focus shifts to achieving value for money, VFM. VFM is typically assessed using the 3 E's. 1. Economy, where inputs, resources like staff, materials, premises, acquired at the lowest possible cost, consistent with the required quality. It's about minimizing the cost of inputs. 2. Efficiency. Did we maximize the output achieved for a given level of input, or minimize the input needed for a given output? It's about the input-output relationship, doing things right. Examples: cost per patient treated, pupils per teacher. 3. Effectiveness. Did we actually achieve our intended objectives and desired outcomes? It's about doing the right things to the degree of goal attainment. Examples: improved patient health outcomes, higher student exam pass rates, reduced crime rates. 3. Effectiveness. Measuring effectiveness is often the hardest part for NFPs.
Okay, underpinning all this performance measurement, financial and non-financial, is the need for good information systems.
Absolutely critical. Modern IT systems provide huge benefits: improving operational efficiency through automation, providing better data for decision-making, facilitating communication and control. But the costs are also significant: hardware, software, implementation, training, maintenance, security.
And different levels of management need different types of information from these systems.
Yes, there's a hierarchy. Strategic, top-level management needs highly summarized, broad, often external information, looking long-term, e.g. market trends, competitor analysis, overall profitability. Tactical middle management needs a mix of internal and external data, focused on monitoring and controlling departmental performance against budget, often over months or quarters. Operational lower-level management needs detailed, internal, real-time information for day-to-day control of specific tasks, e.g. daily production reports, machine efficiency.
And the absolute game changer in information recently has been big data. What exactly is it?
Big data refers to the massive, complex data sets that traditional data processing tools struggle to handle. It's usually characterized by the 3 V's. 1. Volume. Just the sheer scale of data being generated and collected, often terabytes or petabytes. 2. Variety. Data comes in many forms: structured data, like numbers in databases and spreadsheets, but also unstructured data, like text from social media, emails, videos, audio files, sensor readings. 3. Velocity. Data is often generated and needs to be processed at incredibly high speed, sometimes in near real time, like financial market data or website traffic.
And sometimes a 4th V is added.
Yes, veracity. This refers to the quality, accuracy, and trustworthiness of the data. With such huge and varied data sets, ensuring the data is clean and reliable before you base decisions on it is a major challenge. Garbage in, garbage out still applies, just on a much bigger scale.
What's the impact of big data analytics on performance management?
Immense potential. Techniques like data mining, finding hidden patterns and correlations, and predictive analytics, using past data to forecast future trends, can lead to much better targeted marketing, improved operational efficiency, example predicting machine failures, enhanced customer service through personalization, better risk management, and more informed strategic decisions.
But there are downsides or dangers too.
Definitely. The cost of implementing big data infrastructure and hiring skilled data scientists is very high. There are significant regulatory risks, especially around data privacy and security, like GDPR. The risk of theft or loss of sensitive data is enormous. And there's the issue of employee monitoring. The ability to track employee activity in minute detail can create intense pressure and potentially lead to dysfunctional behavior, as employees focus only on the metrics being tracked, sometimes unethically. #tagged 4.5 exam preparation and essential tools, Chapter 23.
Okay, Before we wrap up with a final thought, let's get really practical. All this fantastic technical knowledge about costing, variances, performance measures, it's completely useless if you can't apply it effectively under pressure in the computer-based exam, CBE, environment. Mastering the CDE interface isn't optional, is it?
Absolutely non-negotiable.
Yeah.
It's the critical bridge between understanding the concepts and actually passing the exam. You have to be comfortable and efficient navigating the ACCA exam software.
What are the key tools within the CBE platform that students need to be proficient with?
Okay, on the top bar of the screen, you've got the online calculator. It has both basic and scientific modes. You need to be quick with it, especially for things needing powers or roots, like in learning curves, or maybe even basic stats if regression comes up. The scratch pad. This is like a digital notepad for rough workings. Crucially, remember, the marker does not see or mark your scratch pad. It's purely for your own use. Don't put final answers there. The flag for review option. Essential for time management. If you're stuck on an objective test question, flag it, make your best guess, and move on. You can come back later via the navigator if you have time.
And the tools on the bottom bar.
The navigator is key for moving between questions, especially in sections A and B, and for seeing which ones you've flagged.
Yeah.
And, very importantly, especially for PM, you have access to the online formula sheet. You absolutely must know what formulas are provided, like the learning curve equation YAXB, the MRA2BQ equation, maybe some variance formulas, so you don't waste precious memory space or exam time trying to recall them.
And practice is key across all sections.
Essential. You need to simulate exam conditions on a computer platform. That means practicing. Section A. Multiple objective test questions, OTQs. Section B. 3 objective test cases, OT cases, each with a scenario and 5 related OTQs. Section C. The 2 big 20-mark constructed response questions, which require detailed answers, often involving spreadsheet work and written interpretation in the word processor and spreadsheet response areas.
Speaking of Section C and spreadsheets, speed and accuracy are vital there, right? Especially for things like linear programming graphs, variance calculations, or relevant costing schedules.
Totally vital.
Yeah.
You cannot afford to be doing complex calculations manually or writing out long explanations of formulas in the word processor. You must use the spreadsheet tool effectively. Set up your calculations logically, use cell references, use built-in formulae like SEM, maybe basic arithmetic. The marker can see your formula and follow your working, so clear layout and correct formulae demonstrate understanding much faster than manual calculation.
And if students are finding setting up those Section C spreadsheets maybe for LP constraints, or those tricky planning and operational variances a bit daunting under time pressure.
That's exactly where dedicated practice tools become invaluable. The comprehensive video guidance and practice questions available through SmartPass tools, for instance, are specifically designed to help you master that CBE interface and apply the technical knowledge efficiently in the exam format. They bridge that gap between theory and practical application.
And for keeping that knowledge fresh and getting quick, targeted insights on specific PM topics as the exam approaches.
Yeah, for that ongoing support, quick refreshers on relevant costing rules, tips for interpreting variances, reminders on balanced scorecard perspectives, definitely make sure you subscribe to the SmartPass YouTube channel. It provides those essential bite-sized pieces of exam support and practical advice that can really make a difference in managing your performance effectively leading up to the exam. #CashOutro. So we have covered a huge amount of ground today. A real deep dive into the ACCA PM syllabus, hitting everything from strategic costing like ABC and target costing, optimizing decisions using LP and throughput accounting, right through to advanced variance analysis, modern performance measurement like the balanced scorecard, and the impact of technology and big data.
The technical depth is certainly intense, but remember, the most critical step you need to take now is to move beyond just listening or reading and get into active, hands-on, computer-based practice. You have to apply these concepts repeatedly in the CBE environment to build both speed and confidence. It's the only way to make it stick under pressure.
And always remember, performance management isn't just about calculating the numbers. It's fundamentally about understanding the behavioral impact of those numbers. Why did costs go up? Why did efficiency fall? How will measuring performance in a certain way influence how managers act?
Exactly. So as you continue your studies this week, here's a final provocative thought for you to mull over, linking back to that crucial goal congruence conflict we discussed. If you were a divisional manager, currently measured by ROI, how would switching to a residual income RI measure fundamentally change your behavior when evaluating that next borderline investment project? Would you suddenly give the green light to a project, one that benefits the whole company that you might have rejected under the old ROI system, just to protect your divisional percentage? Think about how the metric drives the decision.
A great question to ponder. Until the next deep dive, keep working through those calculations, keep practicing those interpretations, and good luck with your studies.